With this shaft done, now we're going to work on this impeller. Now this impeller has wear surfaces here and here, so we're going to get this mounted up. Normally I make a separate arbor, but this time we're going to try using the shaft to mount this. So we'll get this set back up in the lathe, slide this guy on, and we'll go ahead and clean up those surfaces. The next step is to go ahead and get this impeller cleaned up. The dimensions are not critical. We are making the bushings. What is critical is the gap between this OD and the ID of the bushing. So we'll come in here, we'll clean this up, we'll make this other one the same dimension, and then once we have that, we'll write it down and take note when we go to make the bushings. See, this is running nice and true. I'm gonna come up here and touch off. I indicated this side of the shaft in before we got started. So we are very true, and this should be true because we cut that center. All right, so that's not fully cleaned up. We got a little mark in there. Otherwise, it looks pretty good. Then we're gonna come in, we're gonna feed in. I'm gonna take a less aggressive cut, a lower feed rate. Now normally you don't want to back out of the cut like that, but this side is a little more worn, so we're going to take this down a little farther so it can match. So we'll get a measurement on this surface, and then we will make our next cut and update our DRO. Next, we need to make these rings out of bronze, and these go on over the impeller. They're like wear rings. So we're going to come in here and bore this out, and then turn down the OD. These ones have a groove for an O-ring and then a hole to locate them in the housing. The only thing that's tricky about this is the hole diameter needs to be about 15 thousandths larger than this nominally. The material they gave me was a little oversized. So hopefully we can squeak that out in this material, and if not, we're going to need some other material. So let's come in here first before we get too excited and try to bore this out and see where we are on size. Unfortunately, this material is too oversized to make the parts we need to make. So what we're going to do is get this out of the machine and move on to one of the bearing housings, and the customer is going to bring us the right material tomorrow, and we can get right back to this guy. All right, the next part we have on deck are these two bearing housings. This bore in here is basically undersized by about 2 to 3 thousandths, and it's out of round. And a mechanical seal goes in here. So we need to come in and clean up this and clean up the face. And then we're gonna machine an 1/8 inch out of this and just a little bit out of the bottom so we can make a sleeve out of bronze that we're gonna press in there. So let's come in here and get this cleaned up. And then what we'll do is we'll zero everything out, and then we'll swap in the other one and bring it to the same point. Make sure we got good clearance. Come in here and take a quick measurement. Cleaning up that shoulder. There we go. So we did 90 thousandths from the shoulder down, and we took out 2.7. So I'm gonna get the other housing in here. So that means that our bushing is gonna be 2.7 plus a little bit for the shrink fit, and the shoulder is only gonna be 90 thou thick. All right, with both of these guys done, we can take this material and come in here and make 2 new sleeves. So we can sleeve this for our 2.5 inch nominal mechanical seal. All right, we're gonna get the liquid nitrogen going. Now that we got these guys shrunken in here, we're gonna come in here and just clean this up with a boring bar and make sure we get our shoulder of 90 thousandths that we removed. We'll slow down our RPM there. It was working fine, but All right, we got both of these bearing housings sleeved and we're all good to go here. We're going to move on to the next housing we need to sleeve, which is back here. They have provided what I'm going to call like a quick sleeve in cast iron. So we're going to bore this out and sleeve this. And I believe, does that fit this bearing? Nope. That sleeve might be for this guy here. Nope. Nope, I think it is for that bearing, and I think it's oversized, which it should be. So we'll double check it. Yeah, it's for this bearing here. So we'll go ahead and get this set up in the lathe, and then we'll get this bored out. We'll shrink fit this in with the liquid nitrogen, and then bore it out so that it's a nice fit on this bearing. We are ready to sleeve this last part while we wait on that bronze. Ultimately, this part's a little tricky. I spent about 45 minutes dialing it in. This is a set true chuck, so I get it, I used the tailstock to get this bore flat on the front, clamped it, and then used the set true to kind of dial it in. Best I could do is get it about 5 to 7 thousandths. That's a lot more than I would like. But unfortunately, this is cast, this is cast, this is cast, this is damaged. The only referencing surface is this outer machined lip, and I'm assuming this is similar to an engine in bill where it registers off this lip, so that's what I'm trying to reference. However, we have damage on this lip, or it's out of round, or both, and in some areas it reads fine, other areas there's like a 5 thou drop off, and it's kind of hard to say how close it is. So we got it as best we could, and that's what we're going to do. But in this case, honestly, I'd probably leave it. This bearing is a pretty tight fit. You want the OD to be like a nice slip fit. And to be honest, the risk of changing the axis to me is greater than trying to fix this for a nice fit when it's already pretty dang nice. But I'm not the one making that decision. So we're gonna go ahead and get it sleeved. There is some pitting in here, which may be why they want to address this. But honestly, this bore isn't too bad. And with that, in conjunction with not being able to really indicate it great, I just don't feel great about it. But that's what we're here to do, and that's what we're gonna do. So we're gonna get this bored out, and we have our nice cast iron sleeve. The last one I did of these, it was out by like 5 or 7 thousandths out of round. This one seems to be within a 1/2 thou, so that'll work great. We'll get it bored out, get that shrunken in there, go from there. Obviously this looks like it's walking a lot more. It's because the casting is out around. All right, we got the liquid nitrogen going. We're gonna pull it out. We're gonna measure it. And then if we need to get it back in, we'll get it back in. Right now we're at 299, which is 2 thousandths under. So I'm gonna get it back in. Let it chill for 15 seconds. We're technically few thou under, see if we can get a little bit more out of it. We're not going to measure it this time. We're just going to be quick. Here we go. It's a little scary, I'm going to be honest. I really don't want to take this out, because if I take it out, I have to re-indicate it. I'm going to buff it a little bit. A lot of surface area. That's exactly what you don't want. You know what, here's what we're gonna do. We got it in the lathe. We're gonna use a tailstock. It's a little risky, but that way if something goes wrong, we got the press right here. Wow, that was an excellent idea. Whew, man. Whew, take a breath. I'm gonna pour that back in there, and we're gonna gently bore this out. Thank you, American Pacemaker. All right, we got this finally fitted out. We have the bearing here. Don't want to get it stuck, but it's a nice fit. Might be a little on the tighter side, but I always like to have it just a smidge tight. It's always easy to buff it out a little bit if you need to. It's obviously hard to add material back, and that's why we're redoing it, because it was oversized. So in this case, if you put it in square, slides in. You know, if you put it in cocked, obviously it doesn't. But yeah, use the bore gauge, which I hate. I'm learning to use this, but I really don't like this. And we use these guys, and then we also test it with the bearing, and then as we crept up in size, we finished out with polishing. All right, guys, we're back, second day. We have some new material the customer provided. It's extremely wasteful, but hey, it's what we had, and that's what we're gonna use. So we're gonna get the OD turned down, take care of the ID, we'll cut the O-ring grooves, and then we'll get these guys parted off. 3.734. We got the OD finished and the ID finished. We're gonna cut our grooves with our parting tool, and then we'll part one off, and then we'll repeat the process for the second one. We're over here at the blue lathe for the final operation in the lathe. Just getting rid of this burr here. Come over here, we have a nice 6-jaw chuck. All right, we're done with the lathe work. We just gotta drill a hole in each of these over at the mill. All right, we got these set up in the mill, and I have a stop set up. So what we'll do is we already center found this edge, jogged over 3125, 1/4 inch hole, very straightforward. Let's get to it. Do a double check on the visual, make sure that's right. Yep, that's good. All right, we're happy, let's send it. Now while this is still in the vise, I'm gonna mark. All right, let's get this one out. Get this one in, double check, looks good. Well guys, this job is done and ready for customer pickup. If you guys enjoyed this video, let me know down below in the comments. And other than that, we're gonna do a little bit of a bonus section at the end where we talk through each part, some of the issues and difficulties we had and how we overcame that. So if you wanna stick around for that, great. Otherwise, we'll see you on the next one. All right, this is a little bit more free form. We're not gonna edit anything here. We're just gonna kind of go with it, and I'm gonna talk through each part and some of the issues we had, some of the difficulties, whether it was easy or not, and what we did that may be unusual or different or unique or whatever. So I can learn and you can learn and I can get your guys' feedback. So let's start with the very first part, that is the shaft. Now these shafts, I feel like I'm fairly comfortable making. They are a fair amount of work, more than you would think, mainly because of the tighter tolerances. So at least for me in my shop, what I have learned is I can't machine these bearing journals to final dimension. I just can't do it. It's too risky. So what I typically do is I machine all bearing journals in my shop to 3 to 5 thousandths oversize, and I polish the journals down. It seems to give me a good result. I don't know if that's how a lot of you guys are doing it, but it works well for me, and it prevents me overshooting the dimension and scrapping the part, which I have done many, many times, and I'm trying to learn and get better, and I think we are getting better. So in terms of this part, we had an issue with the bearing journals, and that is I did an excellent job making sure they were oversized, and while I was measuring one of these journals, I can't remember which, I thought to myself, you know, something just doesn't seem right. And I went and double checked my Quantu mic, which I never double check, which is on me. I pretty much use that as the gold standard in my shop for checking things. And the mic that I was using was about 4/10 off on the small side. And honestly, I started to panic because, as you know, bearing journal fits are, you know, a battle of tenths. And I think I was like 6/10 over on a couple of these, and the parts were still a tad warm, and I was very, very nervous. I went ahead and ordered some bearings because I didn't have some. Those aren't them, these are them. The customer hadn't brought them to me yet, and the next day I came back in and checked, and the fit is gonna work out just fine. I can't get the bearings on, so they need to be heated up to get on anyway, which is as they should be. But I caught that mistake, and that issue is on me. I have had those for 2 or 3 years. I checked them and set them when I got them, and honestly, I haven't double checked them since then. And obviously I know you should every couple months, but I just trusted them. And in my case, I double checked the other 3 that I had, and they were all spot on. I mean, they're very, very close. But somehow the one I was using for this size, it drifted, and it drifted, in my opinion, in a way that is unideal. Obviously, if it was oversized a little bit, you know, that would help us out, but it drifted in the wrong direction somehow, and so we got that redialed in. So from my perspective, I need to do a better job every couple months just double checking with the standard, the micrometer, because specifically on the bearing fits, it is critical when you're trying to chase down those very, very tiny decimals. Other than that, on this keyway, I overcut this keyway, which isn't a problem. Basically, I made an assumption. I assumed that they were using a normal keyway, or what I will call normal. Most of the stuff that I do, the keyways are square profile, meaning that this is a 3/8 keyway and this is a 5/16. So 5/16 is 5/16 wide and 5/16 deep. I've actually had this problem in the past with this customer in a little bit of a different way. But basically, the key that they are using is a non-standard, which I know there's a lot of standards. But to me, it's a keyway that is 3/8 by, I think it's a 1/4. So it was a little shallow. And to be fair, the drawing didn't really have the best detail on that. But I know, you know, they need it to work. So when I cut the key, I was looking at the old shaft and I was like, you know what, that just doesn't look right. I pulled out the key and I noticed obviously that the key is not square, it's rectangular. And so basically they were using a shorter key. Very easy fix. I went ahead and just bought a square profile key. So I got them a 3/8 key. So it fits right in there. It's not going to be a problem. The stick out is going to be the same and it's no issue. But from my standpoint moving forward, I need to just double check that. And guys, I'm just being honest with you so you know how it is. I have been doing this 4 years, completely self-taught. I don't really have a good mentor. I don't have a good teacher. I know that I'm doing well considering that information, but a lot of the guys out there doing this work have been doing it 20, 30 years, and there's no replacement for practice. And that's just what I gotta do. I just gotta keep working, keep getting better. And yeah, nothing is ever gonna be perfect. We can just do the best we can. So in this case, this shaft, it's gonna be great. All the other dimensions are very, very close, within tolerance. The issue with the key is good and the bearings are good, which is the most critical part. And in terms of the shaft, that's pretty much good to go. The OD, we didn't even kiss. In my opinion, I would have liked to kind of touch that up so it's nice and round. It does not matter, but if the stock was a little larger, we could have addressed that. But aside from that, that's pretty much everything with this shaft. Moving right along to the impeller. So typically with the impeller, what I do is I create a stub arbor in the lathe. So I will turn down a piece, slide the impeller on there, and that allows me to turn this concentrically. It works very well. but this time I decided to do things a little bit different. I think it worked out well, actually. I used the shaft that I made and was already set up in the machine to run the impeller on. And that was nice because in this case, this impeller is double-sided. So if I did a stub arbor, I'd have to do quite a bit longer of an arbor. So that way I could get to both sides. But what ended up happening with this, which isn't really a mistake, but you know, it's just kind of, hey, life happens type stuff, is we did the one side, we took off like 40, 50 thousandths and it cleaned up. And usually it's a little bit of a gamble on these, right, in terms of the wear. You want to take off as minimal as possible, and you're making the bushing. So it doesn't really matter the number. What matters is, you know, what the clearance is between these two parts when you're done. And obviously the OD matters on the bushing. So I took off whatever that was, a minimal amount. It cleaned up. I took a little bit extra just to be sure that when I moved to the other side, you know, there's a little bit of wiggle room, so that way if I matched the same number, that this would work. And in reality, I could make one size a little bigger and one size a little smaller and have these match, but I think that's bad practice. I think it's better to have both sides be the same. That way whoever's installing it doesn't have to make a mistake. And when we went to cut the other side, it was damaged more, and that measurement didn't clean this up. Now, in doing that, the material that I was given was too small at that point, right, or too large rather. Now that's not on them or on me per se. Honestly, for the one side, it would have been very close, but probably worked. But for the damage on the other side, it was a little bit too undersized. So once we got that additional material, which was, you know, way overkill in terms of its thickness, it did work out fine, but that did slow us down for a little bit on that part, and we had to kind of burn up a little bit thicker of a material than ideally, but other than that, this turned out pretty well. After we did that, we moved on to the housings, and the housings, I feel like I definitely struggle more with the ID precision fitting than the OD, just because of my measuring techniques and what's available to me. I am really good with the snap gauges and am comfortable with them. I also have a bore gauge that I am learning to use and get comfortable with, but it's always harder, in my opinion, to do ID measurements accurately than OD. With the OD, I can just take my Quantum mics, mic the OD, and we're all good. But obviously with this, it's an indirect measurement. I come in with a snap gauge or a bore gauge, I have to set it off of something, and ultimately, you know, that is a little bit more difficult. Now, the good news is the fit on the OD of a bearing arguably is a little bit less critical. Technically, a bearing should be a mild press on a shaft and should be a slip fit on the housing, you know, or around about there. A lot of people don't, you know this, but the bearing should be able to actually rotate in the housing slightly. So you don't want the housing super tight on the bearing. And you know, obviously when there's weight on it, it's not gonna rotate, but as things expand and contract, the inner race should be pretty well fixed, but the outer race should be able to float a little bit. And that happens from having the right fit on the OD, and that fit is oversized. It's not a press fit. So the tolerances are just a little bit different on that. I think we did a good job getting the tolerance on this. I do like to run it a little on the tighter side, because if they decide they want it to be a little looser of a fit, it's super easy just to hit it with a flap wheel and, you know, take out a few tenths. But ultimately, like this bearing, you know, if you get it in here square, kind of drops in, you know, maybe a little tapping. So, but otherwise, you know, the fit is good. And I bore it out using that indexable carbide boring bar with the modular head. It does a great job, minimal deflection. And then I hit it up with a flap wheel. Following the same procedures, I get it within like 2 or 3 thousandths, and then I will buff it until it gets real close. This time around, what I did was I kind of combined measurements. So in the past, I would stick with just the snap gauges, but to really kind of make me feel a little better, what I did is I picked up the bearings, right, just to test fit, and I measured it with the bore gauge and my old way, which is the snap gauge and the Quantum mic, and I kind of synthesized those, you know, just to say, hey, are both of them kind of giving me the same idea, or is one against the other? And you know, that's helping me. I am still a long way to go, in my opinion, to where I'm just, you know, going over to the machine and super, super comfortable, just nailing it every time. But you know, this it's a little tricky, at least in my opinion. The shrink fit, I think that I overdid it. I think that I went for a 4 thousandths press fit, which is definitely aggressive, but with the diameter being like 3 inch or 2.5, it's like, I don't know what the math would be, like a little under 2 thou per inch. And the dry ice or the liquid nitrogen does freeze it down quite a bit. And when I measured it, it was a couple thou undersized, probably like 3 or 4. So the math worked out, but in reality, we had to use a tailstock to press it in, and it was a little bit hairy. So obviously it's not going anywhere, and we did get it in and everything's golden. But I think in the future, maybe going for a 2 thou press fit on a diameter like that total, or maybe 1.5 would be better. It would just be a little less dicey when you go to install it. So it was either that, or maybe the, you know, the bore was slightly tapered, or more than likely this shrink fit bushing was, you know, not 100% perfect, because I've had problems with these not being round, you know, out a couple thousandths. This one was close. It was within 5/10 or a thousandths, but I've had other ones where they're a lot farther off. So maybe that was what was going on when we were trying to get it in. But other than that, we got this done. It turned out good. It's going to work fine. The one problem we did have was indicating this in. I spent like 45 minutes indicating it in. Usually I'm pretty quick with that, but you know, with all the faces here, it's just really hard to get it dialed. We had one machine face, and the best I could do is get it plus or minus 5 thousandths, or I guess 5 thousandths total, which would be like, you know, plus minus 2.5, which is a little outside the window for what I would like. But ultimately, you know, when this is the only machine face you have, you know, you only got to do the best with what you got. So I think we got it. Moving on to these guys, I screwed these guys up. I'm going to be honest, I showed you guys, you know, what I showed you is what we did. I redid these 3 times. And the reason for that is I just made my measurements, and then I forgot the shoulder. So the first time I pressed these in, there was like a gap in the back, and I was like, what the heck? And it turns out that I just had this dimension that I had on my drawing, which was 435, and I didn't add the lip, which was another 90 thousandths, which is like 450 oversized. And so I made the bushings too short, and I had to machine them out. And I made that mistake on one of them, and then on the other one, I made another mistake where I overshot the dimension by 10 thousandths. It was just a slip. So I ended up redoing both of these twice. Luckily, wasn't too bad. It's not a ton of material, and I was able to not have to redo the bores. I got it machined down to, you know, within like 2 thousandths of bronze material there, and the whole thing just kind of pulled out, and I could start over and re-shrink them in. I'm grateful that I have the liquid nitrogen. Definitely makes things a lot easier. In the past, I have pressed these in, and the pressing does work, especially if it's like 1 or 2 thousandths. But the liquid nitrogen, super nice. You can just drop the part in, get it cold, drop it in. No dramas, no worried about galling. So I really, we got these right. We got them done properly, but I had some issues, and those issues were definitely on me. So in terms of that was those parts. On to these ones. These were pretty straightforward. We had the issue with the material, which is fine, we already talked about. Other than that, making them was no problem. I think the only problem that I have, and I'm curious to see what you guys think, is in the bottom of this bore, I used a 2-flute carbide 1/4-inch end mill to cut this hole instead of a drill bit. And it left a burr, and it is a sharp new end mill, but it left a burr in the bottom. That burr is gonna disappear in 10 seconds when they turn this on. I'm not worried about it, but coming in here and chamfering the ID of a hole inside of a bore, you know, I need a better tool for that, because I was using this. Obviously it doesn't fit. Obviously it's on a radius. I don't want to come in here and file it because you know, I know they like this smooth, so I just opted to leave it. And you know, when they go to install it, it still installs fine. I say it installs fine, and then that one doesn't install fine. So maybe I need to file that one down just a little bit more. Oh, now I'm a liar. Okay, I test fit it. There it is. But that burr, there's like 15 thou clearance, and that burr is definitely around there in thickness. And I really just didn't want to go in there with a file, but maybe I'll have to. But other than that, these parts turned out fine. So that's kind of the rundown on all of these parts. You know, nothing too crazy, but you know, I want to share it because those of you guys who are learning need to know that, you know, everything is not all fine and dandy. And some days I walk in here and I just nail these parts and no issues, no mistakes. Other days I make mistakes, and you know, there's no way around that. So we all just got to learn from our mistakes and try to give the customer the best possible quality product we can. And when we make a mistake, try to make it right. And that's what I try to do. So I hope you guys enjoyed this little explanation at the end. If you have suggestions on tools or different ways to do this, let me know. I'll read them in the comments. And other than that, we'll see you on the next one.